Friends, now we will discuss about the invertible functions. Invertible functions. A function is said to be invertible if there exists a function g such that y 2x and g of is equal ix and f of g equal iy. The function g is inverse of f and it is denoted as f inverse. There is a function f such that x to y is invertible if there exists another function, that is g such that y to x and g of f is equal to ix as well as f of g is equal to I for your identity function of x and this iy means identity function of y. The function g is the inverse of f, which is denoted as f inverse. So g the inverse of f, and you can write f inverse is equal to g. Now a function is also invertible if f is 1 1 and also on 2. This is another case. You can apply the case 2, that is f is 1 1 and also on 2, then invertible. F is invertible. We'll apply this if inverse of f is not to be determined. Clear? If both the processes are correct, whenever you can apply, but it is advisable to find the inverse of a given function if f is not the inverse of the function is not to be determined, right? Otherwise, finding up 1 1 and on 2 to prove inverse is easy procedure. For example, f such that n to y, capital N to y, the function f is your 4x plus 3 and y such that small y belongs to capital N, y is equal to 4x plus 3 for some x belongs to n. F is invertible, find f inverse. That means you have to prove f is invertible, then after you have to find f inverse. So now question, what is given? F is a function from capital N to y. What is y? Y is a set containing the elements of natural numbers and y is equal to 4x plus 3. Clear? Now what is the f? F is a function that is equal to 4x plus 3. For this, you have to prove whether the function is invertible or not. Clear? First case. We will apply both the procedure. This procedure, that is FOG and GEO procedure, and second also. Now for first case, as y belongs to capital Y and f of x is equal to 4x plus 3. What is x? X belongs to natural numbers. Then f of x means generally you can say y. Y is equal to 4x plus 3. From this we can find out x is equal to y minus 3 by 4. X means g of y. So g of y is equal to y minus 3 upon 4 for all y belongs to capital M. Similarly, g of f is equal to g of f, that means g of f of x. Clear? So g of f of x is equal to 4x plus 3 minus 3 by 4. Instead of y, write f of x. So f of x minus 3 by 4. You can write like this: f of x minus 3 upon 4. Next step is f of x is given 4x plus 3. So 4x plus 3 minus 3 by 4 gives you x. That is your IN. Now what is f of g? Is your f of g of x. So f of g of x means instead of x write g of x. So 4f g of x plus 3. It is 4. What is g of x? X minus 3 by y. Right? G of x is 4x into y minus 3 by 4 plus 3. So it is y, where y is equal to identity function over y. Capital Y this is. Okay, this is IN, this is IY. So y is inverse. So x is equal to y minus 3 by 4. You got. Now x means f inverse y is equal to y minus 3 upon 4. Now what is the function inverse of function of what? X instead of y, write x. So f inverse of x is equal to x minus 3 by y. This is one way. Alternate procedure is for 1 alternate procedure. The given question f of x is equal to 4x plus 3. So let f of x1 is equal to f of x2. Then 4x1 plus 3 is equal to 4x2 plus 3. You can solve it. You will get x1 is equal to x2. So f is 1 1. Similarly, f of x is equal to 4x plus 3 given. F of x measure y equal to 4x plus 3. From this you can find x is equal to y minus 3 upon 4. Okay, where y belongs to, x belongs to n and y belongs to capital Y as per the question. Now f of, instead of x write y minus 3 by 4 gives you 4 into y minus 3 by 4 plus 3, and this is y. So f is onto 1 1 and onto, hence f is invertible. And as x is equal to y minus 3 upon 4, x means your f inverse y equal to y minus 3 upon 4. Therefore f inverse x is equal to x minus 3 by 4. X is equal to x changes to y. Okay, in this case. Clear? This is an alternate procedure of the same question. Now we will discuss one theorem related to this inverse function. Theorem is f such that x tends to y and g such that y tends to z, h such that z tends to s. We have to prove that h of g of f is equal to h of g of f. For this, LHS you can take, or from RHS you can find h of, from LHS, h of g of f of x is equal to h of g of f of x. Clear? And this is h of g of f of x. Clear? Now RHS, h of g of f is equal to h of g of f of x. Now h of g of f of x, simple. Instead of O, write the bracket. So therefore LHS is equal to RHS. This is true for all x belongs to capital X. Clear? Another theorem. This is one theorem. Another theorem. Theorem 2. F such that x tends to y, f is a function, and g such that y to z, and both are invertible functions. Invertible. Then g of f is also invertible with g of f whole inverse is equal to g inverse, your f inverse of g inverse. G of whole inverse is equal to f inverse of g inverse. Proof. How can I prove? See, we know f inverse of g inverse of g of f. What will you get? If you get Ix and g of f of fn inverse g inverse, if you get Iy, then the function is invertible. Now for this f inverse of g inverse of g of f, you can expand f inverse of g1 of g of f, right? You can write f inverse g inverse of g of f. Then it is f inverse I y of f. It is f inverse of f, so it is Ix. Similarly, second part, that is g of f inverse of g inverse is equal to g of f inverse of g inverse. So g of f inverse of g inverse is equal to g of Ix of g inverse equal to g of g inverse is equal to Iy. Clear? Therefore, the g of f is invertible. Okay, we prove this with the help of identity functions. Clear? This is one theorem. Now we will discuss the applications, that means questions from book. Okay. Question number 5. Many bits are there. First bit, I am not writing the question. First bit is your many one, because f is given 110, 210, 310, 410. So many 1, 2, 3, 4 ranges. Your codomain is 10. Domain is 1, 2, 3, 4. So it is a many one function. So it is not invertible, because you know for inverse the function must be 1 and 2. This is for bit 1. bit 2 is, yes, your G is given 5 4 6 3 7 4 and 8 2. Here also 7 4 and 5 4. The codomain is same, so it is not 1 1. This is also many 1, so not inverse. That is not invertible. B3 is given H is equal to 2 7 3 9 4 11 and 5 13. These are the order pairs of the given function H. Here, if you think about the domains are 2, 3, 4 and 5, whereas codomains are 7, 9, 11, 13 and distinct elements, you can say objects, have distinct image. So it is 1 1. So it is 1 1. Clear? Now for every y belongs to Z, there is an element n. For every y belongs to Z, there is an element x belongs to x such that h of x is equal to y. How? Listen, in the question your h is given 2 3 4 5 2 3 4 5 2 7 9 11 13. This is the question. So here 7 9 11 13, that's why y belongs to Z. There is an element x belongs to x such that h of x is equal to y. So it is onto function. Clear? 1 1 and onto, so it is invertible. It is invertible. Clear? Now question number 6. Given f such that -1 to 1 two real functions are real numbers, you can say f of x equal x upon x plus 2 is 1 1 given. Is 1 1, it is given. You have to find the inverse of the function f such that -1 to 1 -1 1 to range f. Clear? Here given is f such that -1 to 1 and f of x is equal to x by x plus 2. Now for 1 1 you can write f of x, let f of x1 is equal to f of x2. So implies x1 upon x1 plus 2 is equal to x2 upon x2 plus 2. Clear? By cross multiplication, what will you get? x1 x2 plus 2 x1 is equal to x2 x1 plus 2 x2. So after solving, we will get x1 is equal to x2. So it is 1 1. F is 1 1. Now for onto, as f of x is equal to x upon x plus 2, you can say y is equal to x upon x plus 2. Cross multiply and we'll get yx plus 2y equal to x, and then x common, 1 minus y is equal to 2y, implies x is equal to 2y upon 1 minus y, where y is not equal to 1. Now f is how? See, replace x in place of here x has 2y by 1 minus y in the given function f of x. So f of 2y by 1 minus y is equal to 2y by 1 minus y divided by 2y by 1 minus y plus 2, solve it, 2y by 2y plus 2 minus 2y, you will get y. Clear? So y, therefore f is onto. So the given function is invertible in -1 to 1 or is range f. Clear? Okay. Now what is the inverse? If it is asked to find the inverse, then inverse is as x is equal to 2y by 1 minus y, then x is equal to f inverse y equal to 2y by 1 minus y. Therefore, inverse of the function is in terms of x, you have to write that is 2x by 1 minus x plus y by x, simple thing. Then question number 8, f says that r plus 2 for infinite, where f of x is equal to x square plus 4. For 1, same procedure will follow. Let f of x1 equal to f of x2, then you can write x1 square plus 4 equal to x2 square plus 4, implies x1 is equal to x2. Why? See, square terms either plus or minus, both you will get, but here x1 and x2 belongs to r plus, only positive reals. That's why you can write x1 equal to x2. So it is 1 1. F is 1 1. Now for onto, f of x is equal to x square plus 4 implies y is equal to x square plus 4. So x is equal to root over of y minus 4, where y minus 4 is greater equal to 0 as y is greater equal to 0 because y belongs to r plus. Clear? X is equal to root over y minus 4. So f is onto. Therefore f inverse exists. Now what is f inverse? F inverse x is equal to f inverse y is equal to root over y minus 4. So f inverse x is equal to root over x minus 4. Okay. Similarly, you can solve the whole exercise. Thank you.